Okay, here's a wild idea for you. What if the secret to understanding the absolute chaos of the stock market wasn't hidden in some complex financial model, but in the laws of physics that govern the planets? Today, we're diving into a pretty radical concept, applying Isaac Newton's physics directly to economics. I know it sounds a little out there, but stick with me, because this could completely flip how we think about our entire financial world.
So here's the paradox that gets this whole thing started. We can predict the path of a comet with, stunning accuracy, years, even decades in advance. But a massive market crash? We're often totally blind just weeks before it happens. So why is one so perfectly predictable and the other just so chaotic? Well, it's possible that economics has been operating with a huge piece of the puzzle missing this whole time.
The real problem, when you get down to it, is how each of these fields thinks about change. Now, both physics and economics are causal, right? A cause leads to an effect. Simple enough. But here is the critical difference. Newtonian physics is dynamic. It's built from the ground up to describe motion and change over time. Traditional economics, on the other hand, is basically static. It gives us a snapshot, like a single photograph of where supply and demand might cross, but it tells us absolutely nothing about the journey, the actual movement of the market to get to that point.
So how do we fix that? How do we build that missing dynamic element right into the heart of economics? Well, the answer is to go back to the beginning and create a whole new blueprint, using the foundations of both fields.
This timeline really shows you how these two ways of thinking developed on completely parallel tracks. In 1686, you've got Newton publishing his masterpiece, Principia, laying out the laws of motion. A century later, Adam Smith comes along and sets the stage for modern economics. Then, way over in the 1890s, Alfred Marshall gives us those static supply and demand curves we all know. But do you see that gap? That's where our opportunity is, to finally connect Newton's dynamic physics to Marshall's static economics.
Let me put it another way. Early physicists, they understood static electricity, like a spark or getting a shock from a doorknob. But they couldn't really describe a continuous electrical current. That's what James Clerk Maxwell did for electrodynamics. He gave it the math to describe flow and change. And that is exactly the goal here, to create a kind of economic dynamics that can model the flow of a market, not just a frozen in-time snapshot.
So how on earth is this actually done? The method is, well, it's a systematic translation. You take the core ideas of physics and you find their direct one-to-one counterparts in the world of economics. Let's break down how that works. Before Newton, the old way of thinking, even from brilliant people like Kepler, was that planets needed a constant push to keep moving. Like angels flapping their wings to keep them in orbit. Newton's truly radical idea of inertia basically fired the angels. He realized an object in motion just stays in motion. You don't need a force to sustain it, you only need a force to change it. So, what's the economic version of inertia? It's demand. Just think about the global flow of oil. It doesn't need a new push every single day to keep going. The simple, persistent presence of demand for oil is what keeps that flow moving. In this model, demand is economic inertia. It's the natural tendency for a flow of goods to just keep on flowing. This table right here, this is basically the Rosetta Stone for this whole new model. Physical motion becomes trade, the flow of goods. Inertia, as we just saw, becomes demand. An object's resistance to change, its mass, becomes price inelasticity. The push or pull that changes an object's motion, force, that becomes our wants and desires. And finally, acceleration, the change in motion, well, that becomes our needs, which is really just a change in what we're demanding. Okay, so now that we have this translation key, we can do something really powerful. We can completely rebuild the most famous graph in all of economics, supply and demand. The classic model you learned in school has some, let's say, major quirks. First, it treats supply and demand like two totally separate forces. It also, for some weird reason, puts the cause price on the vertical axis, which is just backwards. And because it's only that static snapshot, it has no clue how to handle things like negative prices, like paying someone to take your trash away. And it definitely can't describe the actual motion of a market over time. So let's rebuild it step by step. We start with the classic X-shaped curves. Now we introduce a single zero reference point. And here's the key move. We define supply as simply being negative demand. Think of it like a number line with positive and negative values. When you do that, the two separate curves just collapse into one single unified line. Suddenly, you're not locked in as a supplier or a demander. You can be either one, just depending on which side of zero you're on. And this simple change leads to a huge insight. Price is no longer just a static number. It's a vector. Now, in physics, a vector has both magnitude and direction, and that's what price has here. It has a magnitude, how much, and a direction. Are you bidding for something, moving in a positive direction on that line, or are you asking for payment to take something away, moving in a negative direction? That little addition of direction is what makes the whole model dynamic.
All right, let's put all the pieces together and see the elegant, dynamic economic law that emerges from this whole new way of thinking.
Everybody remembers this one from high school physics, right? Force equals mass times acceleration. F equals ma. It's the engine of all of classical mechanics. It tells you that the force you apply to something is directly proportional to the acceleration it experiences. It's beautiful. And now, using our translation, we can write the economic equivalent. Our wants, which is the force driving us, equals the price in elasticity of a good, its economic mass, multiplied by our needs, our economic acceleration. It is a direct, perfect translation of Newton's second law. It's an F equals ma for the marketplace, the dynamics of desire.
Look, this isn't just some clever academic exercise. When you build economics on a Newtonian foundation, you give it the tools to actually model change over time. It transforms economics from a science of static pictures into a science of dynamic processes. And that can unlock the kind of predictive power that it's been missing for, well, more than a century. And all of this leaves us with one last big thought. This entire journey has been about taking powerful foundational ideas from one field and using them to solve a huge problem in a totally different one. It really makes you wonder, if economics has finally found its Newton, what other fields, from sociology to biology, are just sitting there waiting for someone to find theirs?